Welcome to another explainer. Today, we're basically putting on our detective hats and stepping right into the emergency room of database performance. If you've ever just stared at a sluggish application, pulling your hair out wondering why a single query is bringing your entire system to an absolute crawl, well, you're definitely in the right place. We are going to look at the ultimate diagnostic X-ray tool for your database, MySQL Workbench's Visual Explain. So picture this scenario. You get a panicked message. Your application has a staggering 12-second page load time. The users are completely frustrated and the clock is loudly ticking. You quickly identify the slow query and run a traditional text-based explain command, crossing your fingers for a quick answer. But instead of a clear solution, you're just hit with this overwhelming, cryptic wall of JSON or tabular text. Trying to trace the exact order of operations and spot the bottleneck in thousands of lines of raw text is literally like trying to read the Matrix. Okay, let's dive into this. Look at the stark contrast here. Instead of a jarring, dense wall of text, MySQL Workbench's Visual Explain gives you a super clean, intuitive, directed acyclic graph, or DAG for short. It takes that exact same complex JSON output, which actually contains all the detailed cost estimates from the MySQL optimizer, and it magically transforms it into a beautiful flowchart. This shows you the exact data flow and exactly where the heavy lifting is happening. It is an absolute game changer for your optimization workflow. Section 1. Decoding the visual diagram. To catch our database culprit, we first need to learn how to read the visual runes of this diagram. It's a specific language, but once you understand the grammar, you can diagnose performance issues in a matter of seconds. So let's look at the flow and the shapes. A visual explain diagram executes from the bottom to the top and from left to right. The leaf nodes down at the very bottom are where data is first retrieved, and the shapes, they tell you exactly what kind of operation is happening. Standard rectangles represent your base tables. Diamonds, those represent join operations. Rounded rectangles indicate operations that manipulate the data after it's retrieved, things like sorts or groupings. And those framed boxes, they encapsulate entirely separate subqueries. And this brilliantly illustrates how the tool acts like a thermal map for your query's performance, using color to guide your eye directly to the problem area. Blue and green nodes are healthy. They represent super low-cost operations like primary key or unique index lookups. Orange nodes are your moderate cost areas, typically representing range scans, where MySQL is scanning a subset of an index. But red means high cost. Angry red screams danger. If you see a red node, that is your prime candidate for optimization. Let's zoom in on the anatomy of a single node. The metadata inside these boxes is basically your smoking gun. In the top left corner, you have the relative cost of the operation. Over in the top right, you'll see the estimated number of rows MySQL expects to process. Right dead center is the access type, and this tells you exactly how MySQL is fetching the data. Finally, at the bottom in bold, you see the key, which is the specific index being used. Now, if that key area says null or none, you know for sure you have a serious problem. Section 2. The 3 deadliest operations. So the crucial point is, when you're diagnosing a sluggish database patient, there are a few primary suspects, specific tumors really, that show up time and time again. These 3 specific operations are the absolute most dangerous suspects. If you see an access type of all, or an extra info warning that says using file sort or using temporary, your query is doing vastly more work than it ever should be. Let's break down exactly why these are so lethal to your performance. The absolute most severe hotspot you will ever encounter is that red all access type. This signifies a full table scan. Imagine trying to find a very specific item in a massive warehouse, but there's no catalog, no aisle numbers, no organization whatsoever. You are forced to open and check every single box. That is literally what MySQL is doing here. It's reading every single row from disk or memory because no suitable index exists to guide it. For tables with millions of records, this is just devastating. Next up, we have 2 massive CPU hogs. First, using file sort. Now, this doesn't necessarily mean it's writing to a physical disk. It might actually happen in memory, but it does mean MySQL has to do an expensive extra pass to sort the data. This is usually caused by an unindexed order by clause. Second is using temporary. This means the database is forced to create an internal temporary table just to hold intermediate results, often due to really complex groupings. Both of these will slow down your response time significantly. Section 3. Prioritizing fixes by cost. When you're staring down a massive query with dozens of joins, you might see multiple orange or red nodes. So how do we know which one to tackle first?
The answer lies in that little number at the top left of the node. The MySQL optimizer uses a cost model that actually aggregates CPU and I/O costs into a single relative metric. An operation with a cost of 10? Fast. An operation with a massive cost, like, say, 8,000? That is a major bottleneck, dragging your entire system down.
Now, what's really interesting about this approach is that it teaches you to be ruthlessly efficient with your time. You don't need to fix everything all at once. Target the nodes with the highest relative cost, combined with massive rows examined estimates. Fixing the single most expensive node first yields the biggest, most immediate performance return for your entire application. Section 4. Solving a live support ticket. All right, let's put this theory into practice. The alarm bells are ringing for a live support ticket on our Sequila sample database. The user transaction history page is taking a staggering 12 seconds to load. It's time to scrub in and perform some surgery. We're going to follow a strict, methodical process. First, we take the slow query from that 12-second ticket. Second, we run it right through Visual Explain in MySQL Workbench. Third, we use our new X-ray vision to identify the missing index causing the bottleneck. And finally, we apply the fix and verify our patient's recovery.
And here is our X-ray. Looking at the output, the culprit is just glaringly obvious. Right at the base of our query execution, we have a massive, angry red node on the transactions table. The access type is all, our dreaded full table scan. The estimated rows are over 1 million. The relative cost is a massive 8,000. And hovering right over the node, we see the using file sort warning. The database is reading 1 million rows and sorting them all from scratch every single time a user loads this page. No wonder it's slow.
We've got our diagnosis, so now let's prescribe the cure. The query is filtering by a status column, and it's sorting by a created_date column. To fix this, we're going to execute a DDL statement to add a composite index that covers both of these specific columns. By doing this, we are giving the database engine the exact roadmap it was missing, allowing it to jump straight to the relevant records and read them in the correct sorted order. Let's see how this builds. We apply the index, we rerun Visual Explain, and look at that relative cost number. It has absolutely plummeted from a catastrophic 8,000 down to a beautifully efficient 12. The operation is now incredibly cheap for the database to execute. Just contrast the before and after here. It is literally night and day. We went from a cost of 8,000, an angry red all node, and an expensive file sort, to a serene, perfectly healthy green node. The access type is now a lightning-fast index range scan. That file sort has been completely eliminated because the database is just reading the rows in order directly from our brand new index. That agonizing 12-second page load is now executing in milliseconds. Surgery was a complete success. Visual Explain isn't just a tool, it's a completely new way of understanding how your database actually thinks and works under the hood. It translates invisible, abstract performance data into a clear, actionable picture. So I'll leave you with this final thought. Grab the absolute slowest, most painful query in your application today, open up MySQL Workbench, and run Visual Explain. What secrets are hiding in your worst query right now? Get in there and find out. Thanks for joining me on this explainer, and happy optimizing.